Welcome to this explainer. Today, we're diving into a genuinely fascinating turning point in human history. I want you to imagine, just for a second, standing on a shoreline right before the 14th century. The open ocean? It wasn't a highway back then. Actually, it was terrifyingly known as the Green Sea of Darkness. Going too far out literally meant certain death. And it wasn't for a lack of bravery. It was a massive, incredibly dangerous mathematical and physical puzzle. So today, we're looking at the actual science behind 1400, how specific, tangible scientific sparks around that year finally solved that puzzle and ignited an era of global exploration that entirely rewrote humanity's understanding of our planet.
So what exactly sparked global exploration in 1400? Before the massive galleons and the sprawling global trade networks, what foundational leaps in science made it all possible? We often picture these early explorers as these romantic lone adventurers just braving the unknown through sheer willpower. But the reality? They were essentially the astronauts of their day, operating on the absolute bleeding edge of applied physics, mathematics, and technological innovation.
Section 1. Dawn of the Age. To really understand the catalyst here, we first have to set our parameters and look at the intense initial motivations that were pushing humanity out into those deep, unknown waters. The crucial thing to grasp first is this exact time frame, the Age of Sail, running roughly from 1400 to 1860 CE. This 460-year stretch saw absolutely unprecedented voyages across the massive expanses of the Atlantic, Pacific, and Indian Oceans. Because before 1400, deep-water navigation was practically impossible. Traditional square-rigged ships just couldn't sail against the wind, and navigators had zero reliable ways to find their latitude out on the open water. Crossing an ocean back then meant overcoming some seriously daunting scientific roadblocks.
So why take such insane risks? Well, necessity really is the mother of invention. At this time, overland trade routes, like the famous Silk Road, were totally fractured or just entirely monopolized. European nations were feeling intense commercial and strategic pressure to find a direct sea route to the hugely lucrative spices and silks of Asia. This massive economic bottleneck created a really urgent demand. They desperately needed better, faster, and much safer ways to travel. And it was exactly this fierce imperial competition and pursuit of geographic knowledge that ended up funding the incredible scientific research and development of the 15th century.
That brings us to Section 2, the science of sailing. Because, as we know, ambition alone is not nearly enough to cross an ocean. You can want it all day long, but you need applied science to actually pull it off. And this is where the actual mechanics get super fascinating. To survive those brutal ocean waves, shipbuilders came up with the caravel. They brilliantly combined traditional square sails, which were fantastic for speed, with triangular lateen sails. These lateen sails acted a lot like modern airplane wings. They generated aerodynamic lift that allowed the ship to actually sail at an angle into the wind, a total game-changer of a process called tacking. Plus, to avoid getting hopelessly lost in a completely featureless ocean, sailors adopted the astrolabe. By measuring the precise angle of the North Star above the horizon, the astrolabe let navigators calculate their exact latitude anywhere on Earth using pure geometry. Literally overnight, the chaotic, trackless ocean suddenly had a mathematical grid. Starting from that foundational math and engineering laid down around 1400 CE, we see an astonishingly rapid progression. These exact scientific leaps directly enabled mind-blowing feats, like the Magellan-Elcano circumnavigation between 1519 and 1522. Just imagine trying to cross the vast Pacific Ocean, a body of water so massive it covers a third of our planet. They pulled us off using dead reckoning. They were meticulously calculating their exact speed using just a knotted rope thrown overboard and a sand glass. They relied completely on raw math to survive without seeing a single visible landmark for months on end.
Moving on to Section 3, the global exchange. Because once these scientifically advanced ships actually started connecting distant shores reliably, the consequences went way, way beyond just drawing new coastlines on a map.
By totally accelerating global trade networks, these massive leaps in maritime technology kicked off an unprecedented swap of plants, animals, technologies, and ideas between completely isolated societies. This ecological phenomenon, often called the Columbian Exchange, essentially rewired the entire planet. For instance, navigational science is literally the only reason the nutrient-dense potato made its way all the way from the Andes Mountains to Europe, completely revolutionizing global agriculture and skyrocketing population growth. The world suddenly became a whole lot smaller, and this massive exchange permanently transformed diets, economies, and really human history as we know it. Which leads us to Section 4, Floating laboratories. You see, as the era progressed and the world got more interconnected, the very core purpose of these expeditions started to shift dramatically.
Early on, the primary focus was basically raw commerce, finding gold and establishing imperial dominance. But as the centuries rolled on, early expeditions gave way to later ones, and these vessels physically evolved into literal floating laboratories. By the time we get to explorers like Captain James Cook or Charles Darwin on the HMS Beagle, the ship's cannons were literally making room for telescopes and botanical samples. Expeditions were being launched for purely scientific reasons. They were carrying dedicated astronomers across the globe specifically to track the transit of Venus across the sun, which, by the way, helped us calculate the actual size of our solar system.
The direct result of putting dedicated naturalists, ethnographers, and astronomers on these ships for months or years at a time was an absolute explosion of data. Entire fields of modern science were essentially born out on these voyages. Take oceanography, for example. Navigators meticulously recorded water temperatures, they mapped incredibly complex global trade wind patterns, and they charted massive underwater currents like the Gulf Stream for the very first time. This incredibly specific data permanently changed how we understand Earth's atmospheric and oceanic engines. It turned the sea from this terrifying mystery into a fully measurable, predictable system. But as we know, progress is relentless. The incredibly deep understanding of fluid dynamics, standardized mechanics, and global logistics that was developed during the age of sail actually laid the direct scientific groundwork for the very inventions that would eventually replace it. The careful mastery of physics required to build highly efficient, wind-powered wooden ships directly informed the thermodynamic principles and industrial networks that fueled the steam propulsion and metal hulls of the modern era, right around 1860. The era that connected the world quite literally engineered its own obsolescence. So I want to leave you with this final, provocative thought to ponder. How did the staggering amount of data gathered on those fragile wooden ships permanently alter humanity's understanding of our planet? Think about it. The wooden caravels of 1400 were absolutely the space shuttles of their day. They ventured into an absolute void using cutting-edge math, geometry, and physics. The scientific sparks of that era finally proved the world was a measurable, deeply connected sphere. So, the next time you see a modern rocket launch, just remember the centuries of wind-powered science that first taught humanity how to explore the unknown. Thank you so much for joining me for this explainer.